Hello, everyone. Thank you for joining our webinar today, Risk in Fruit and Vegetable Processing, EMP Focus. This webinar will be hosted by Joelle Masso. I'm Amy Knock, and I'll be moderating this webinar. Before we begin, I just wanted to let you know a little bit more about how it will run today. The webinar is being recorded, and the slides and recording will be available for you within 3 business days. A short Q&A session will follow the presentation to answer any viewer-submitted questions. During this webinar, you can submit questions you have using the webinar sidebar menu. Select the Questions tab, type in your question, then hit the Enter key on your keyboard. Remember, you can submit questions anytime throughout the webinar. And at this point, I will turn it over to Joelle. Joelle, you may begin your presentation.
Thank you, Amy, and welcome everybody to this presentation on risk in fruit and veg processing, a topic near and dear to my heart. And we're really going to focus in today on environmental monitoring and how we approach that in produce processing, given some unique challenges that the category has. My name is Joelle Masso. I'm the Associate Chief Scientific Officer for Produce for Eurofins, and my contact information is on the slide. Please do reach out. I'd love to hear from you, meet you, and get any feedback that you might have in regards to this topic or something else. With that, we'll go and we'll get kicked off here on our agenda. And really, before we get into how do we design an environmental monitoring program, specifically for produce, we kind of have to start by thinking about how do we approach and think about risk in food and managing microbial risk in food as well as the produce industry. We'll then incorporate that information into how we design a better EMP program and what we're really doing with that EMP program to get a comprehensive program. So that's what we're going to attempt to do. So if you have questions, please do fill them out while I'm going, and we'll address them, as Amy said, at the end of the presentation. So when we think about food production and kind of the food industry, how do we as a society control microbe risk in food? And there's really two really big buckets that I'd say with controlling microbe risk. There's the product itself, which we'll start by talking about, and then there's the facility. So if we look at the product management, how do we control the inherent risk that there might be from a microbial food safety risk and or even a spoilage risk when it comes to food products? We do that with good manufacturing practices, good agricultural practices, supplier management, basically looking about how we handle the product itself in processing to make sure that we aren't introducing and or potentially that we're mitigating risk. We then design our HACCP programs, our hazard analysis and critical control point programs, and our HARP-C, the FSMA equivalent, the hazard analysis and risk-based preventative controls for our products to make sure we identify what those microbial risks are and that we design our process to the best of our ability to control it. Historically, and certainly still some of our best tools in our toolkit are water activity and pH. So water activity just being how much free or available water is in a food product that's not bound to something that microbes would have as food, effectively the ability to grow. The lower the water activity, the more we can control microbial growth because water is critical, obviously, to life. pH, we control microbe growth with pH. A lot of things don't like to live at very, very low or acidic pHs or very, very basic pHs. So if we can design our food products to have low water activity and either very low pH or high pH, mostly it's low, we can control some growth as well. Cooking, if we're so lucky, can mitigate some risks as well as freezing. So maybe it doesn't get rid of the risk, but it at least doesn't allow it to grow. And if you're really, really lucky, you have a pasteurization step or a kill step to achieve that 5-log reduction that lets you take some, sigh of relief when it comes to microbial risk in your food product. Now that we have our inherent risk with our food product, we also need to think about where and how we're producing it. And with that, we have the facility and processing risks. We're going to look at our sanitation programs to make sure that we're not making it dirtier in our food production area. We have to really hone in on equipment design to make sure our sanitation program can actually clean our equipment, as well as that it's effective in whatever we're trying to do with it. And then we look at our process design And that can be an all-encompassing kind of topic, but it's effectively like where you store your raw product and how you bring it in and the traffic patterns in your plant to make sure you're not, introducing or increasing risk. Maybe it's the high to low or your hygienic zones and things like that. And it's really this area that we're going to be talking about most today. But there is a connection to product management, which is why we're starting out kind of the overall approach. Here are some common organisms of concern when we're thinking about microbial risk. Most of them are pathogens, but I do want to highlight, especially in produce industries, is that spoilage organisms can be just as detrimental in terms of meeting your shelf life, making sure you have happy customers. If anyone who's bought some fresh cut fruit or veg and opened it up and smelt something it's less than favorable, it's just as detrimental if you're not controlling spoilage organisms in your environment. As it is to kind of think about some of the pathogens. So unfortunately for us, when we do kind of our risk assessment about produce, we find that we have pretty much most of the foodborne pathogens that we need to think about. In respect to environmental monitoring, we generally talk about Listeria, but I've put up all these other ones because Listeria may be more apt to be our foodborne organism of concern, it's certainly not the only one. No one has told these other organisms that they're not allowed in your facility. So you do need to incorporate them just as you do in your risk assessments for product management to think about it in regards to your environmental monitoring programs. Now, the produce industry specifically has some added fun. It's a very dynamic industry in that lots of things change. And unfortunately, that means your food safety and your food risks can change as well. You have variable supply chains. It's not uncommon. In fact, it's very common that you're going to change your supply geographies throughout the year. You're going to change your suppliers, that you're rotating fields and orchards so that you're pulling in different types of varieties and or working on soil management. So every year you have a variable supply chain, and within the year you have a variable supply chain. These things can impact what kind of organisms are coming into your site. You also might have seasonal quality issues, and those can vary drastically year by year and certainly day by day. Perhaps you had a heat spell or a cold snap, and that's going to change the microflora that's on your product. It's also going to change what's coming into your facility. And unfortunately, for designing an EMP program in a produce plant, is that you generally have to think of it in that dynamic nature. It won't be the same need throughout the year. So we're really going to focus in on that later in the conversation. But just remember that is that due to variability and dynamics in food safety for fruit and vegetables, is that we often have to think about our EMP program being dynamic. Short shelf life. So this in and of itself isn't necessarily a food safety risk. I think the thing that makes short shelf life hard to manage in fruit and vegetables is that you may have spoiled products that maybe is more apt to be a food safety issue, but also that every decision that you make has a very quick time frame that you need to make it, which can make managing food safety risks very difficult if you're having to make a decision in a very short time. Adjacent land use. So this one's a big one because you've used a ranch or orchard forever and you've never had an issue and you pretty much know what the risks are. But what if the land use around you changes? You might not even know it. What if a farm suddenly puts in a cattle farm next door or puts in a poultry facility? It's on you to basically know that your risk may have changed, which may change how you handle your product as it comes in. Same thing with animal intrusion. If suddenly the land next to your orchard or ranch that you're sourcing product from has been commercialized into even a parking lot, all of the animals that might have been in adjacent fields could move into your field, or maybe a new migratory bird pattern. All of these things impact food safety risk when it comes to produce processing, and importantly is that they're dynamic. It's hard for you to know when and how they're going to change, but you need to be, responsive to recognize that your programs may need to be modulated throughout the year to manage food safety risk. Unfortunately, most of us have a lack of a kill step, which means we're ultimately managing a certain level of risk. We don't have the luxury of a 5-log reduction where we handle it, we put it through our process, and then we ship it out the door 100%, 99% sure that it's safe. So we're always trying to figure out how do we manage a certain level of risk. The risk from the product, we went through all those pathogens that might be there, the salmonellas, the pathogenic E. coli, the listerias, some viral risks that we have to think about, and we have to think about how they change over time. We have the risk from the process, that's the part that we do. How are we handling the product? Are we introducing more risk in our facility? And our key really that we're trying to design, whether it be from product risk management or whether it be from facility risk management, is to how do we keep that risk, that in certain level of risk, at the normal level or below. What we really don't want to do is think about how we might be actually increasing risk, right? So unlike other categories, the produce industry adds another layer of dynamics as well as another concept of really managing a certain acceptable amount of risk because we don't have the luxury of some kill steps. All right, so I told you we were going to talk about environmental monitoring, and I just spent a lot of time talking about product risk. Why did I do that? Well, because of all that variability with fruit and vegetables and the inherent risks that come in with the product, that's introducing potentially risk to our facility. And then our facility, if we don't manage our programs well, our sanitation, our good manufacturing practices, et cetera, can become a risk to our product. And because we don't have a kill step, it's a very critical relationship to recognize is that it is bidirectional. If you bring in dirty product and or just regular product that has soils and leaves and all these different vegetable matter products, you could also be bringing in what is a dirtier load to your facility. If your EMP programs and sanitation programs are not sufficient to clean that up, daily or within the shifts, it's going to be potentially cross-contaminating other product that comes through the door. It is extremely bidirectional in fruit and vegetable processing because of that. So it's something to think about and land in your head is that your product risk assessment is very much related to your environmental monitoring program, not to be exclusively just about listeria, okay? So in short, agricultural items can be a facility risk, and certainly facilities can be a risk to agricultural items. So that's that bidirectional relationship that we really need to think about when designing our environmental monitoring program and also in handling our product. So let's start with environmental monitoring now. We have this nice serene look of the ocean here, and it's calm and it's very inviting, and it's pretty much like you're saying right after sanitation, right? It's your facility, it's all clean, it looks great, and you're ready to start production. But what if there's sharks beneath the surface? And that's what environmental monitoring is. If you were a lifeguard on the beach, what your job is to identify the sharks before they find the swimmers, right? And that's what your environmental monitoring program is doing, is that we're trying to find risks prior to any kind of bad occurrence from happening. So EMPs are surveillance activities. We're looking for the sharks before the sharks find the swimmers. We're focusing on finding risk, and we're going to use tools to do that. We're going to identify trends, hopefully, and areas of risk when we're setting up our programs. And we'll go through this in a second. But first, let's start with the concept of tools. So to develop a surveillance program, we need to have a way to do that. And I called it a tool. Mostly you think about environmental monitoring in respect to testing, right? We're going to do some testing to see the sharks that we can't visibly see because these are microorganisms. So how are we going to go about it? We're going to use a tool. And when you think about microbial tools or any kind of diagnostic tools, I like to equate it to like a bathroom scale, something that's pretty ubiquitous. And the thing about a scale, right, is that if you're trying to lose weight, you get on and off the scale. It's going to tell you your weight, but it's not going to help you gain or lose it. That's going to happen from everything that you do, when you're not on the scale. Are you going to go ride your bike or go run or go eat less? So a scale will just tell you what you're at. It won't help you gain or lose weight. It'll just help you guide where your issues are or if you're getting productive feedback. Something to note too is anyone who's ever had a scale that's off, besides being extremely depressing when you maybe find the accurate scale, is that some scales could be broken, some scales may not have the resolution you need, right? So if you're trying to lose 5 pounds, but your scale only has 10-pound increments, it's going to be pretty hard for you to know if you're successful. So you have to really think about how are we going to pick, our tool. The other thing about when you're using a scale, when you're trying to gain or lose weight, right, is that your weight changes throughout the day. So when should you hop on the scale? Certainly, if you want to know when you're the lightest, you can figure out what time of the day you need to hop on that scale. But that may not be your true reflection of your weight. And that's certainly true in environmental monitoring. If you're worried about your product, what your product might experience, doing testing at the very beginning, right after sanitation, may not be the most reflective assessment of your risk. So these are all components that we need to think about when we're designing environmental monitoring. What kind of tool are we going to use, and how do we use it? So we'll go more into that. So we've called it the surveillance method, right? We're trying to find the sharks before the sharks find the swimmers. So testing is a mean of verification. And what does that really mean? We'll go into it. It can identify a risk, but it doesn't alone change it, right? It's the bathroom scale. The bathroom scale can tell you what you weigh, but it's not going to help you gain or lose weight. That's the same thing with testing in environmental monitoring. Your impacts or your actions following what you learn from using that tool, that's what's actually going to impact your risk. So we need to think about that, because often when we talk about environmental monitoring, or when somebody asks a question like, well, how do you manage your facility risk? People say environmental monitoring programs. That's actually not true. Your environmental monitoring program is just telling you what other actions you're doing, whether or not they're working. So it's not necessarily the thing that's changing your risk level. The other thing is to remember is about that bathroom scale, right? No tool is perfect. And the key is you have to identify the best tool for what you're trying to do. And recognize that, there are assumptions and limitations to every tool. So having a very diligent and cognizant kind of thought process about what to use and when, that's a very critical piece of designing your EMP program. So we'll start at where to monitor. And these are probably things that you've heard before, but we'll go over them briefly. So we separate our facility into different zones, mainly so that we can be effective at trying to identify areas of higher risk and make sure that the mitigations we put in are in place. So zone 1 testing is actually product contact testing. So it's touching your product. You may have heard about this in respect to, everyone says don't do pathogen testing for zone 1 because it could lead into recalls. Certainly the concept is, right, if you do find a pathogen on its zone 1 surface, it would be very difficult to prove that you don't have a problem on product. And so that can lead to recalls if you do find that. So that's one thing to think about. That being said, zone 1 is also probably the surface that you're most worried about, right? You're most worried if you're introducing risk to your food product. Something to think about. Zone 2 is effectively the area right adjacent. So if zone 1 is a conveyor belt, then zone 2 is the support structure right next to the conveyor belt. So it can give you an indication if you have a zone 1 problem by looking at zone 2. Zone 3 is still in your production area or in your processing area, but it is not near adjacent to zone 1. And zone 4 is outside of the processing area, but can give you an indication as if you have outward threats or in your break rooms or things like that. So what are we going to look at to monitor? And I've got a couple things to think about, right? It's like I've said a few times that most of the time people with environmental monitoring are looking at listeria, because we all think if you have a cold, wet plant, listeria is going to be the thing that you're most worried about. And certainly that is true, but it is not the only thing, which is why we started this presentation by really talking about what kind of risks are you bringing into your facility. And, colloquially, I guess everybody has said, well, dry plants, if you do dry processing without water, you're more worried about salmonella, because certainly salmonella is more dry resistant, right? It is more capable of surviving in dry environments. So I've worked with many people who have dry plants who just look for salmonella. And then suddenly they decide to look for listeria, maybe at the request of a customer or whatever, and find an enormous amount of listeria in their dry plant. The lesson to be learned here is that while there are indications, certain environments are more conducive for certain organisms, it is not necessarily 100% conclusive, meaning nobody told Listeria that it doesn't like a dry plant. You may still be able to find it. So think about what's coming into your process in your areas, and know what you're trying to manage and what's your risk. So having a very structured approach to, do I need to know if there's the pathogen? Do I need to know if there's indicators? So if you're looking at the pathogens, right, Listeria monocytogenes is the species of Listeria that we are most worried about. But you need to know just monocytogenes, or do you not want to know it at all if it's a zone 1 testing area? So be diligent and, I guess, cognizant of what it is you're trying to learn, because the environmental monitoring program is a surveillance activity that's going to give you information to better design your programs. So if we look at this graph or this picture here, we have many different ways we can approach environmental monitoring that are inclusive of pathogens and would be indicators. So whether those are Listeria species, the generic E. coli, whole form, Enterobacteriaceae, which are big groups of bacteria that include within it pathogens potentially of concern. Those would be considered indicators. Or we can just be a very targeted approach, as we want to know if the pathogen itself is there, and we can go at it in that respect too. But these are things to consider as you design your program, and it's in combination to the type of product risk that's coming in your door, and also what you're trying to learn from it. So how to monitor? We have different tools, right? So we talked about the bathroom scale kind of concept. There's a lot of different tools that we can use in environmental monitoring to assess risk. Many are PCR-based or based off of DNA. That's certainly the case for Listeria species and direct pathogen testing. Probably the most ubiquitous test out there right now are PCR-based tests, which are looking to see whether or not there's DNA of that organism there. Effectively, it's the crime scene investigation, of food production plants. Is Listeria there? It doesn't necessarily mean it's living, but is it there based off of genes in your DNA? We have immunoassays also, which are antibody antigen related. So another way of trying to look to see if you have a specific organism there. They tend to be not as fast as PCR-based assays, which is one reason why people move more towards PCR-based. We have ribosomal RNA, which is based off the ribosomal subunits that makes proteins. It's another way that people have looked for evidence of organisms. We have ATP, so this one's a really common one because it's extremely fast. The caution to adenosine triphosphate is that it's the molecular currency of microorganisms, but it's not necessarily directly related. It can also be in plant material. So in produce plants where you have a lot of soil and plant material, ATP can be an indication of whether or not a surface is clean, but it is not necessarily directly correlated to living microorganisms. And then certainly Petri dishes and Petri films, which would be the cultural kind of methods, like are they growing? If you think of those colonies on a plate, that's what these are. So we have a lot of different ways that we can approach environmental monitoring. How do we pick it, right? So that you probably will have heard at some point, fit for purpose for tools in testing. And the biggest criteria I think most people look at, what's the time? How long does it take and how much time do you have to hold product? If you need to, if you're doing zone 1, you might want to hold product. How much, what is the sensitivity? If you want to, briefly, we could do whole conversations about some of its sensitivity and specificity, but sensitivity in short is that if you get a negative, it is actually a negative, that you don't have a false negative, you don't miss it. Specificity is that you don't want to get a positive that's not really a positive, or what we call a false positive. And just to call out that these are related, generally you have to give up some specificity or some sensitivity to increase one of the other attributes. So things to think about and talk to your lab about when you're picking your best tool. Cost is certainly important. I mean, we often don't like to kind of talk about that, but realities are is that if you're trying to be doing diligent surveillance, you may need to do a lot of different samples. So where can you get the most bang for your buck, and how can you get the information that you need, which is the last one. Make sure you're doing whatever tests that you need to do to get the information that you need to design the best mitigation programs. All right, so what does it mean to manage your risk? how do you do it, right? So we have sanitation programs that manage our risk because we clean things and make sure they're not getting dirty. We have good manufacturing programs to make sure that our employees are handling product right, that we're storing things in the right way. We control movement so that we don't have forklift pattern and employee traffic patterns that are going to bring risk from higher, dirtier areas, maybe where you have your bins or your raw product receiving near to your finished product. Maybe you have a pretty rigorous supplier management program. Maybe you're doing risk assessments on ranches and doing assessments on suppliers to make sure that they're doing all these things prior to giving you their product. Good agricultural practices, of course. So we talked a lot about the variability of supply chains and issues that might happen in an agricultural perspective. One thing that's not there in terms of environmental monitoring programs, which is what everyone thinks about when you say environmental monitoring program, is that your testing manages your risk, and that is not on there. And that's because testing just shows you your risk, it doesn't manage it. So environmental monitoring programs can be designed, they can be implemented, and they can be not effective at managing risk because they're just surveilling what's there. It's just telling you your weight. It's what you do with that information that defines whether or not you're going to gain or lose weight, right? So as an example, I'm going to highlight a project that was done for the Center for Produce Safety, which if you're not familiar with them, I encourage you to go check out their website. They have a ton of free information for you to glean from in respect to food safety risks in the produce industry per se. So let's look at the citrus pack shed. So they did a study. Dr. Trevor Seslow at the University of Davis did this study in 2016 to 2018. And we looked at 10 different facilities, he looked at 10 different facilities, and he looked at zones 2 and 3. So near adjacent to food product contact, and then in your production area, and almost 1,500 swabs. So it's pretty sufficient. A lot of different facilities over 2 different years. What they found was 31% of their swabs, of that 1,500 swabs, were positive for Listeria using PCR. And 30% of them were growing. So another webinar for another day, but effectively PCR can detect DNA. It doesn't necessarily mean it's living, but in this case, of those PCR positives, almost all of them were actively growing organisms. They also found over this 2-year period of time that there's a seasonal influence and that you saw fluctuations throughout the year. That certainly is important, right, if you're going to think about how to design your environmental monitoring. Most importantly is that while you had a whole bunch of swabs, right, you had environmental monitoring programs, is that cleaning and sanitation programs were found inadequate. So just because we did testing, it doesn't mean that the management of our risk in these facilities was appropriate. So what was the problem there? It wasn't the testing. It was that we weren't doing good cleaning and sanitation. So now that we've kind of gone how, the why, what we're doing, what do we need to think about in produce processing facilities? And produce processing facilities have some unique challenges because we have a lot of very different specialized equipment. That equipment can change over time. It often is very wet or has dirty material, vegetable material, fruit material, water coming in. Places we really need to look at in fruit and veg plants, our drains, which is true of any food production plant. But again, because of the material we're bringing in, with Listeria especially, it's a common soil-borne organism. We need to think about introducing it and then creating harborage points in our drains, on our belts and peelers and grinders. We have sticky material from the plant or the process that we're doing. All things we need to think about and incorporate into our environmental monitoring programs. We need to be pretty diligent about hygienic zones and design. So really keeping traffic flows and patterns from raw material to finished as separate as possible, because we know we don't have a kill step. So we have to minimize risk physically by just how we move about the plant, how we keep our employees moving things. Where we put our raw product compared to our finished product, or even our finished product packaging in respect to raw product. It's just be very cognizant of where you're storing different things and then make sure that you're monitoring those areas to recognize risk and to be able to identify when risk maybe has been elevated. There's a lot of equipment in produce processing plants, mainly because produce is often very irregularly shaped, and we have to come up with some pretty amazing engineering feats, right, to process these into the value add cut, fresh cuts that we do, or the frozen industry. Because of the sheer size and weight of a lot of the equipment, we tend to use hollow equipment, and hollow equipment isn't always the best when it comes to microbial harborage, mainly because bacteria can get into the cracks and crevices. And it gets back to that question, that I posed earlier on about the bathroom scales. What time of day do you get on and off the bathroom scale changes what risk you'll have. Well, with hollow equipment, once it's vibrating, once it's moving in production processing, it could be actually aerosolizing risk into your zone ones, as well as obviously the rest of your facility. So we really want to minimize hollow equipment because it can actually cause water collection, and water is obviously a big way we control and move product around in fruit and veg processing. The other thing, not necessarily unique, but highly ubiquitous with produce processing is cooling and condensation tunnels, forced air tunnels, ice machines, blanchers, things that create temperature gradients. And temperature gradients effectively can make managing areas harder. One is that they create condensation, which gives you water, which is necessary for growth. But also is that temperature gradients can pull the air literally from areas of higher temperature to lower temperature. And it's one reason we see issues with freezers and IQF tunnels in frozen processing, is that it's actually pulling risk towards the freezers, which then can obviously get into food product contact. The other thing to think about is just airflow in general and heat and air cold units. You can have something growing in your air conditioner unit that then is getting spewed out across your facility. It's important to think about that because that could actually be zone one if it's blowing up atop your actual product. So there are things to think about. It's also seasonal, right? So we talked about seasonality in terms of supply chain and your product itself, but how you manage your plant may vary a lot during the year because of temperature and what you use, whether the heater or the cooler. Often too, people have, this could just be spoilage, but it's certainly a case with pathogens, is that you might get a hot period of time and you pull out all those floor fans, and then everything on the floor, which is often wet and dirty, is getting blown across your facility to keep your employees cooler. And suddenly you don't know why your quality is horrible, maybe in peak summer, but it's maybe not related to your product at all. Maybe it's related to the use of fans on your production floor. Certainly something to look at and make sure you're definitely not using fans that are over trench drains or anything like that, because you could be spewing your pathogens all over your facility. We already talked a little bit about temperature and condensation zones, but think about that also in respect to seasonality. So that case study we showed you with the citrus tax shed, they found seasonal issues. And partially that could be related to product, but it certainly can be related to the temperatures in your facilities and your storage areas, where you see condensation and cooling and just increased moisture. Drip pans and ice buildup. We often don't think much about them. Well, we have a drip pan. The problem is that drip pan is catching liquid, and it can definitely allow for growth. Listeria, it can grow at very, very low temperatures also, so ice buildup and such like that isn't necessarily going to protect you. Now that you've done all this, and you have all this information about where to look, how we're going to collect the data, what do we do with it, right? So environmental monitoring alone means nothing. We really need to look at our data in cumulative. And there's different ways to do it. You can certainly do it. These are two tools that Eurofins has with Europortal. But effectively what it is that you're able to look at your facility and over time identify which zones might be the biggest issue, which site is maybe contributing to your food safety risk the most. Or in the bottom, we can see Enterobacteriaceae. That's actually being an indicator, a group of organisms that's being looked at quantitatively over time to see when we have spikes. It's extremely valuable if you use this information in cumulative, such that you can then maybe change your patterns, increase your sanitation during different times of the years, and really make an adaptive environmental monitoring program. So often when you talk to people about their environmental monitoring, they said it, 5, 10 years ago or whatever, and they just keep implementing it. But as we've talked about in produce processing especially, we have dynamic risk and a lot of seasonal changes. So it may be that your environmental monitoring program needs to change over time so that you can best use your testing dollars to identify and manage risks when they're the highest. Another way to look at it, this is something that Dr. Doug Marshall, our CSO, often presents, but is that you have another way of looking at it is maybe you don't have a facility map, but you can certainly set up an easy kind of spreadsheet like this, where you have each of your sites, and you can look at over time the positivity of that one site in relation to other sites, as well as seasonal based on when you're taking it. So if you look at this one, site 3 has a much higher hit rate than the other sites that we're monitoring in our program. Also is that we can recognize that the first few weeks seem to have more of an issue, more positivity finds than other times of the year. So maybe we've got a seasonal thing. Maybe that's when we're bringing in your product. Maybe the temperatures are changing on our site. So using our data as opposed to just one data point, we learn a lot more about environmental monitoring. We are far more capable of identifying when and why we might find sharks, right? And that's what we're trying to do with environmental monitoring. It's not just telling us, well, I found it or I didn't find it, good for me. It's definitely not controlling our risk. It's allowing us to see our risk. And we can really see it more by looking at data in cumulative and using trending and tracking like this. It doesn't have to be elaborate. It can be something as simple as this. Or we can set up a really simple graph or map like this, right? So it's probably done in Word or Excel. And we can just kind of set up what our facility looks like and where we're monitoring. Maybe one week we find one hit right near that drain. Well, that doesn't necessarily tell me anything. I would expect to find a hit by a drain. Not a big deal. But what if I start finding more? And what if it starts moving up into that slicing and grinding, dicing table? Well, suddenly I've now learned from my environmental monitoring how and what kind of behaviors I need to change to make sure that I'm not getting basically this outward progression of pathogens. Certainly when I look at all these other data points, it looks like that drain's a pretty big problem. So maybe we need to redesign the hygienic design of that drain. Maybe we need to get facilities involved, or maybe we just need to get a constant sanitizer in there to minimize the risk. Certainly, it's become the epicenter of all these tests. Okay? So if we think about that last slide, we're looking at all our data. We've got a lot of hits, and so our environmental monitoring program is finding the problem. The question is, especially in produce processing, when we know we're bringing it in every day on our raw material, or we potentially could be, how do we know if it's transient or if it's actually resident, meaning that our sanitation programs are not eliminating the risk and it's the same organism over time? Well, for that, we need a different type of tool. And so we have typing and different whole genome sequencing, and effectively they're just different tools, subject probably for a whole nother webinar. But some common ones that you've probably heard about in terms of tracking different organisms in your facility would be 16S testing, or whole field gel electrophoresis, or a lot of different next generation sequencing options. And effectively, these tools, like what we talked about earlier, they all have differences and assumptions and limitations. And in respect to knowing whether or not something's transient or resident, effectively the difference is usually a resolution. How specific am I getting in knowing what strain is there? And what do I, again, in terms of fit for purpose, what do I really need to know about it to be able to pick the right tool for what I'm trying to look for? So effectively what you want to make sure is, even though you may have a risk that's coming into your facility every day with produce processing, you want to make sure that your sanitations and good manufacturing practices are not allowing for resident microorganisms, such that that bidirectional flow is that you potentially are contaminating the raw product even more, increasing your certain level of risk, which is what we want to eliminate. So, in summary, environmental monitoring surveils if our mitigation works, right? It's an important thing to remember. Environmental monitoring programs do not manage risk. They tell you what it is. The other thing is activity versus value. So often I'm told, well, I do 100 swabs a week. honestly, you could do 10 swabs a week and maybe have more value. It's really about how you set up your program. So don't think quantity necessarily is value. And don't be afraid to change your environmental monitoring plan if the information that you're getting from it is not helpful. If you're never finding anything, it's probably time to redesign your program. Because if you don't find risk and then eliminate it, your program isn't doing anything to lower your risk. So things to think about. Don't be afraid to change it, and make sure you're designing your programs for your programs for value and not activity. It's very easy to fall into that. Well, I do so much testing. But again, testing doesn't lower your risk. It just tells you what your risk is. Okay? And identify your risk as they come in, and make sure you understand and never forget that your risk is dynamic. And in produce processing, you are subject to even more dynamics because of the variability of your supply chain and where you might be sourcing it and everything that might happen in the fields prior to getting to your facilities. And then certainly your facilities have the same risks as other food industries, but you're often much more diverse in respect to the types of equipment you have. You have a lot more water, you certainly have plant material, and making sure that you adapt your program, maybe do more testing during certain times of the year once you identify your trending issues. Remember that test is just a snapshot in time. So if you're not looking at your environmental monitoring program in cumulative, all your data in cumulative, you're certainly not getting all the value that you're paying for in doing the testing. So set up different ways to evaluate it, dissect it and look at it different directions so that you can understand better the risks in your facility and how you might need to change your behaviors. Build systems to validate and verify and communicate your programs. So besides learning more about your risk as it comes into your plant, a really thing that people don't think a lot about is how you can communicate upwards to upper management about what's going on in your facility, as well as educate and connect dots to your employees. We spend a lot of time teaching employees about good manufacturing practices and bacteria in respect to food safety, but EMP programs kind of complete the picture and can let people see, here's all the efforts that we do, and here are the ways that we're surveilling whether or not it works. And it's a very effective communication mechanism to be able to look at data like that. Ultimately, too, obviously, you can start making decisions on data and not feel, and that's a great value of environmental monitoring programs. Some tools that Eurofins has to help you do that. If you're a Eurofins customer, you have access to our online portals, and these portals keep track of all of your results, quantitative and qualitative, and you can export them. They'll come straight out into Excel, and you can do trends and tracking, and you have all your reports in one spot. So you're one step up in already being able to look at your data and be able to access data. And then certainly reach out to your laboratories. Reach out to me, reach out to other experts within the company. We can help you understand what's going on in your facilities as much as we can. We're all over the country as well as the world, but probably mostly here in the United States. And here's my contact information again. I'd love to hear from you. And with that, I will turn it over to Amy and see about questions.
Thank you so much for that presentation, Joelle. We have received a number of questions in the chat. So again, I want to remind everyone, feel free to submit your questions and we will follow up with you afterwards if we don't have time to address all of them. But the first one that came in here is, how do you know whether to use an indicator or a pathogen?
Yeah, I mean, when we're designing programs, we think about that fit for purpose. So the fit for purpose, one of the last criteria is what information do you want to know, right? And so a lot of that depends on how you're designing your environmental monitoring program and what you're going to use that information for. If you're concerned about zone 1 testing, zone 1 is your highest risk, area. And you want to know if there's a pathogen on there. But certainly there's a lot of fear, and especially with short shelf lives where you can't necessarily hold product, is that if you do zone 1, you're probably more likely going to be using an indicator. Another benefit to indicators is, besides that you don't necessarily end up in a food recall, is that the broader group of an indicator, whether it be Listeria species or other bigger groups like Enterobacteriaceae or even generic E. coli or coliform is that it can show you where you might have niches. And so if you start trending and tracking quantitative data about indicator groups, it can give you more of an indication of where risk is higher. And then if you do some parallel testing with pathogen as well as indicators, you might have a better idea. Maybe like 5% of the time I know that when I have a count of 100 on this, CFU per gram, is that it might be a pathogen. So how you design it, how you use which one, there's no right or wrong answer. It's really dependent on what you want to find from it. And if you're looking for trending and tracking to be able to understand when you have spikes, an indicator may be far easier to use because you're going to see bigger movement. You have more ability to find more organisms. If you're just concerned about pathogens or Listeria, then you can certainly do that as well. So it comes down to what's the purpose and what information do you want to know. And maybe a backwards way of looking at it too is what information do you not want to know, right? If you don't want to know that there's Listeria monocytogenes on your food contact surface, start with indicators. So you can kind of look at it in different directions, but a lot of it depends off of how you're going to use it. So work with your lab, work with, experts that you have to figure out where you derive the most value from it.
Great, thank you for that. And another question that came in, why is there generally less focus on viruses compared to bacterial pathogens?
Yeah, certainly right now in the era of COVID, right, we talk a lot about viruses. So I guess historically, I would say viral testing hasn't been as prevalent because it hasn't been as easy to do. Unlike bacteria, which will grow outside of, an organism, viruses are host specific, and diagnostic testing for viruses can be very difficult because they don't increase in number just sitting there. So, for example, hepatitis A or norovirus have been viruses associated with human illness with produce, but we can't grow those in the laboratory. So effectively, when we do a test for those pathogens, is that we have to extract what is hopefully a very low number of those viral particles and be able to detect them. So somewhat it's been in relation to the difficulties of knowing that they're there and how to test for them, as opposed to bacteria, why we haven't done it. And certainly if we look at the impact that bacteria foodborne pathogens have compared to viral, they tend to be more in the news, as well as your risk increases over time, sitting on the shelf. So that's really why we have been focused more on bacteria over, history than we have viral. But certainly there's emerging issues with viral testing, with viral pathogens and threat in food products. Hepatitis A and noro are two common ones when we think about food production. And as technologies and diagnostics get better, I think we'll start to see that change over time. Certainly that's the case with Hep A and noro. We see more and more testing because we are capable of testing for it now. So I think that will be something we see as an emerging risk that we are monitoring more for in testing in the future.
Wonderful, thank you. And I think we have time for one more question here that came in. So if I keep finding hits in the same location, how do I know if the same organism or just a recurring problem?
Yes, that's something that's pretty common in produce processing, is that, if we're bringing in plant material that has soil and has, potential risks from being grown outside, is that theoretically we know we're going to bring it in every day. How do we get to the knowing that transient versus resident? And that gets into what we had talked about on that one of the last slides, with different technologies to be able to track if it's the same strain. And there's a lot of different techniques to do that, and some are going to be higher resolution in the sense that you could know exactly if it's the same strain. So if we think about it in relation to the hot topic of COVID these days, right, we're talking about the new variants of COVID, of the COVID virus, is that you have mutations on the genetic level that allow you to understand whether or not it's the same strain or a different strain. So if you want to know, maybe you've got a particular area in your drain or in your facility where you keep finding a higher number of hits, and you start to wonder, okay, is it that my mitigations, are my cleaning practices following getting these hits just not sufficient? I'm just not getting rid of it. you probably want to talk to your food laboratories about different test options. And you want to know if it's the same strain that's still there. Because if it's the same one, it's like maybe you've controlled your raw material risk coming in perfectly well, but you just have a harborage point or a seam or a wall even that you can't seem to get rid of that one pathogen. So that's when you need different tools in your toolkit, and it's not going to be the primary tool that you use. So you can look at different things for sequence resolution, next generation sequencing, and really typing to see whether or not it's the same organism that you keep picking up or not. So that's just a different tool that you need in your toolkit for that exploration. And that's an emerging market with a lot of new technology. So it's always good to reach out and find out what's available to you.
Okay, thank you so much for your response, Joelle. And again, that wraps up our Q&A session. And I want to remind everyone, thank you so much again for attending. A recording of the webinar, along with a copy of the slide deck, will be available to you within 3 business days. And I want to thank everyone again for attending today, and we appreciate your time. Thank you.
Thank you, everyone.